This is our bonus lesson that's not in the book. It's called Properties of Parabolas. I'm going to teach you how to graph parabolas just one way, and then later in the year we'll learn other ways that we can graph parabolas. So let's get started. This right here is an equation of a parabola that's in a function form ready to be graphed. We have x stands for the x coordinates, y is the y coordinates, and parabolas, if you don't know, look like u's. If the a is greater than 0, it's going to be a happy u. If the a is less than 0, it's going to be a sad parabola. It's just a little tip. And one other thing before we start graphing them is if you look at this c value, that is your y-intercept. When it's in this form, ax squared plus bx plus c, the c value would be your y-intercept, because if you had a graph and you had if x was equal to 0, then these two would be gone and you would just have your c value, which is what where it would cross the y-axis. So we're going to start out. The first one, I didn't write the directions on there. It says identify the vertex of each. One more term. The vertex is the high or low point. If it's the low point, it's called the min. If it's the high point, it's called the max. So the first one's all we're going to do is find the vertex, which is this point right here, which I never got to. It's a coordinate. It's a coordinate, an x and y coordinate of the highest or lowest point, and that's the vertex. The vertex. So how do you find the vertex? Well, there's a little formula. There's one way you can do it is you can put it into vertex form, but that's what we're going to save for another time, and I think it might be in your book. We're going to use something really simple that you can use when you take the SAT or anytime you want to graph these, is you can find the x coordinate of the vertex by saying x equals negative whatever b is over 2 times whatever a is. So this is the formula you need to memorize in order to graph parabolas. So here we go. Let's find the vertex. We're going to take x equals negative b. Well, b is negative 4, so it's going to be 4 over 2 times a, which would be 4 over 4. So the x-coordinate of the vertex is going to be 1. In order to find the y-coordinate, we put the 1 back in where the x's are. So we're going to get 2 times 1 squared minus 4 times 1 minus 2. And if we simplify that out, we get 2 minus 4 minus 6 is going to be minus 4. So the final thing they're going to ask us is, what is the vertex? We say the x-coordinate was 1, the y-coordinate is negative 4. That would be this point or this point, depending on if it's a happy or sad parabola. And we know if we look at the a value, it's positive, so it's going to be a positive parabola. It's going to look like that, with the vertex right here of 1, negative 4. And if we look at it, it's going to cross the y-axis at negative 2. Let's do one more of these vertex. What you're going to have for homework is to complete everything we don't get done today. I'm going to do most of the evens until the end because they get redundant. So number 4, let's find the vertex. So we use our formula, x equals negative b, which would be negative 12, over 2 times negative 3. So that's going to be negative 12 over negative 6, and we're going to get 2. And then to find the y-coordinate, we just put 2 back in, so we get negative 3 times 2 squared plus 12 times 2 minus 10. And if we put that in, we're going to get 2 out. So our vertex is 2, 2. It's going to be a sad parabola because we have a negative a value, and it's crossing the y-axis at negative 10. So it's going to look something like this, and it's going to cross the y-axis at negative 10. Okay, all that's helpful because now we're going to graph these guys. So I have 2 we're going to put on the same graph, and then I have a third one on the next page. So first thing we want to find is the x-coordinate of the vertex. So we say x equals negative b. So b is negative 6. This is your b. So it's going to be 6 over 2 times negative 1. It's going to be a sad parabola, right? We see that because we have the negative. So we're going to get 6 over negative 2 would be negative 3 would be the x-coordinate, and then we put that in. So we get negative 3 squared minus 6 times negative 3 minus 10. You can use your calculators if you want to do this. And when we put that all in, we get the y-coordinate is negative 1. So our vertex of this parabola is going to be negative 3, negative 1. So I'm going to graph that. Let's use a different color for fun. So the vertex is, so the way you graph it is you go to your vertex. I'm just going to count these. We're not going to be able to get down to negative 10 if I count by, if I make these 1. So let's just make them, let me just split them up maybe into thirds. So this is kind of weird, but it's how it's going to have to be. And we'll split these into thirds, and that way we'll have enough. Actually, I just split them into fourths. 1, 2, 1, 2, 3. No, I didn't. 1, 2, 3, 1, 2, 3. All right, so our vertex is negative 3, negative 1. So here's negative 3, negative 1. So you plot that point, and then you look at your y-coordinate, which is negative 10, and you know that is where it's going to cross the y-axis. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be about here. Now, with parabolas, they're always symmetrical around a thing called the line of symmetry. The line of symmetry goes through the x-coordinate of the vertex. So this is our line of symmetry. I'm having trouble drawing it straight. Our line of symmetry is just x. It's an x vertical line, so it's going to be x equals, and then whatever your x-coordinate is, negative 3. So that's your line of symmetry. That means the parabola could fold in half on that line and be the same on each side. So if we're going to try to find a third point of our parabola, if we walk over 1, 2, 3 and down negative 10, we're going to go to the left, 1, 2, 3 and down negative 10. And that gives you a point of symmetry so that you can connect your parabola. And that's how you're going to draw your parabolas. So you find your vertex, you plot it, you find your y-intercept, you plot it, and then you find a point on the opposite side of the axis of symmetry. And let's do this last one on this page. Yuck, I have fractions here. Let's get a new color. So we have to find the x-coordinate. So x equals, I didn't do this ahead of time, so this could be fun. Negative b, so it's going to be negative 4 thirds all over 2 times negative 1 third. So on the top we get negative 4 thirds. On the bottom we get negative 2 thirds. If we flip and multiply, we're going to get negative 4. If we could just multiply top and bottom by 3, it'd be kind of easier. So we get negative 4 over negative 2. So that works out. We get 2. So our x-coordinate is going to be 2, and we have to put that back in where the x's live, and we will get our y-coordinate, which I'm just going to tell you what it is. You can put that in later. So we're going to get y equals looks like negative 4. So let's go graph that. Our vertex is 2, negative 4. It's another sad parabola. Our y-intercept is kind of tricky because it's a fraction, but that shouldn't scare us too much. It's close to 5 1/3, or it is 5 1/3, so let's graph this one. It's negative 5 1/3. So we have a vertex of 2, negative 4. So let me just divide this one into thirds again. 2 and what did I say the other point was negative 4. So we're going to plot that point, 1, 2, 3, 4. And then we get our y-intercept, which is 5 1/3. So 1, 2, 3, 4, 5 1/3. About here, and we're going to go the same direction. We went over 1, 2 to get that y-intercept. We're going to go over 2 and then down 5 thirds about here, and we connect it and we have our other parabola. And that, my friends, is how we graph parabolas. Let's do a couple more. Number 12, or number 10, we're going to graph this one. One of my numbers went away. The number is, you have to print these sheets out for your homework, or you can just copy them from just the screen. Wow, lots of sad parabolas. I think all the odds are going to be your happy parabolas. So yeah, you'll have much more fun. So here we go. Let's graph it. So we get the x-coordinate. It's negative b, so it's going to be 10 over 2 times a. So it's going to be negative 5. And your y-coordinate is, if you put the negative 5 in here, so it's going to be 25, negative 25 times negative 10 times negative 5 minus 30. Your y-coordinate ends up being negative 5 as well. Wow, negative 5, negative 5. Your y-intercept is negative 30. So there's a couple things we can do, because we could either do our graph really funky so that we get down to negative 30, or we can use another method to get the next 2 points. We can look at the number, the a number. So a is equal to negative 1. We can set that up as a slope for the first 2 points, and I'll tell you what I mean by that. So we're going to plot negative 5, negative 5. Let's see. I didn't leave enough room on here, so let's just divide these in half. And all these in half. We'll have enough room then. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's really hard making these videos when you have a cough. Okay, not good. Now, the way you can use the slope method, we could go down here and put a point on negative 30 somewhere down here, right? It's be way down there, or we could scale it that way. And then we would put our axis of symmetry for this one, if we want to think about our axis of symmetry, is the x-coordinate. So it's going to be x equals negative 5 is our axis of symmetry. The other way that we can do our second and third points is to treat this as a slope. You can only do this with the first point. It doesn't work. Otherwise, you'd have 2 straight lines going down. So I can go down 1 over 1 and put a point, and then down 1 the other way and put a point, and we can make our parabola that way. And that way, you don't have to go the whole way down to negative 30. That would have worked for any of our previous problems. Let's just look at one of those. So let's look at number 6. It would be the same thing. We would have went down 1 over 1, down 1 to the left 1, and you would have got these points. It's good to know both ways for understanding it a little bit better. All right, last problem. And then you have all of the rest. You don't have to graph 11 through 18. They just want you to identify the vertex, the axis of symmetry, and the min and max value of each one. I didn't point out the min and max value, but at this one, the max value of this one would have been negative 5, negative 5. The vertex is the min or max of the function. Oh, you have to tell whether it is a min or max. Well, this is a max because it's at the top. If it's a happy parabola like this, your vertex would be a min. So let's do this last problem, and then I'll set you free on the worksheet. You're supposed to identify the vertex, the axis of symmetry, and the min and max value. So here we go. First thing we need to do is find the vertex. So we use our formula, x equals negative b over 2a. So we put it in, so we get 18 over 2 times 1. Yay, we finally have a happy parabola. And we get 9. So our x-coordinate is 9. Our y-coordinate, we put the 9 in and see what we get. This is going to be fun. And we get, believe it or not, we're going to get our x-coordinate, y-coordinate is y equals 9. So our vertex is 9. Whoops, it should have been 5. What was I thinking? So it's going to be 9, 5. This, since it's a happy parabola, it's going to look like this. So this point is going to be a min because it's the bottom. And our axis of symmetry is just going to be x equals the x-coordinate, which is 9. Oh, the minimum value they want to know. The minimum value would just be how low is it going to go. That would be your y-coordinate. So the minimum value equals 5. And that is how we graph parabolas. So hopefully that was helpful to you. We can go over more of these in class on Thursday. And until then, I guess you need to know something for extra credit. I didn't do that earlier. The extra credit is Noah is the only one home with me today. All right, we'll see you on Thursday.